Hello, Mr. Baker here with another video for you guys. This time I'm going to be talking about law of cosines, some of the stuff that we did earlier today. So, law of cosines. We use law of cosines for two different cases. One, when we were given the information in a side-angle side format, or when we were given all three sides of a triangle. And law of cosines helped us to solve for other sides, or in the case of the side triangle, where we were given all three sides, helped us to solve for the angles. So I'm going to give you two sets of formulas. One is actually the ones that were introduced today in class, and the other is actually something new that's based off the law of cosines that will directly lead you to solving the angles. So we have two cases. One, when we're solving for sides, and this will look like what you had seen in class earlier today. And the other one where we were solving for angles. And this is going to be a shortcut using some algebra to help you kind of cut out the middleman, so to speak, and get straight to the meat of what you're trying to do. So when we were solving for sides, we named three different formulas based off what side we were solving for using this new law of cosines rule. We had a squared is equal to b squared plus c squared minus 2bc cosine of angle A. We also had b squared is equal to a squared plus c squared minus 2ac cosine of angle B, right? The two sides and the included angle. And our last one for the third side was c squared is equal to a squared plus b squared minus 2ab cosine of angle C. Notice that the angle is always matching up to the side that we are solving for. Now, what happens when I'm solving for angles in the case of my side triangle? Well, we can come up with this new little shortcut based off of some algebra using what we know about inverse cosines to find each of these angles by manipulating these formulas. So I'm going to go ahead and give you the shortcut, and you can feel free to use this on your homework, which is that, let's say we're solving for angle A now, right? Angle A would be equal to the inverse cosine of, this would be b squared plus c squared minus a squared all over 2bc. The 2bc comes from here. The b squared plus c squared is translated over here. And the a squared is subtracted. Now, for those of you guys who are wondering, how is this possible? Where is this coming from? If you manipulate this formula as is, without plugging in any values, and solve for angle A, you will come up with this formula. And you can test me on that. So, I'm going to go ahead and list the other ones. Angle B is equal to the inverse cosine of a squared plus c squared minus b squared all over 2ac. And finally, I'm going to give myself a little bit more space, angle C is equal to the inverse cosine of a squared plus b squared minus c squared all over 2ab. So feel free to use these shortcuts when you are solving for angles on your law of cosines homework. Let's do a couple quick examples to give us some practice of solving for these angles. All right, here's a triangle. All right, I'm going to call this triangle jet. Okay, in triangle jet, we'll say that this side is 7, this is 48 degrees, and this side is 8. And this will be the case of my side angle side case. And we're going to solve for JT. Which would be solving for a side. Now, it doesn't really matter which one of these formulas to use, because obviously I didn't label it as A, B, and C, or J, E, and T, because we have J, E, and T. The only thing that I'm really looking for is that B and C are going to be my sides that are on the outside of my angle, meaning my angle that I'm given is between those two sides. The side I'm trying to find here is going to be whatever I'm solving for on the outside. So just for all intents and purposes, we'll call this little e. And how I'm going to set up my formula is that e squared is equal to 7 squared plus 8 squared. Notice that my side that I'm solving for was the side not attached or not nearby my angle, and on the opposite side, 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of that included angle, 48 degrees. So you punch all this in your calculator. 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of 48 degrees should give you e squared is 38.057. Take the square root of both sides. E is equal to 6.169. Again, I'm rounding to 3 places. Those of you guys who have another teacher might not do that. Up to you guys. So there you go. Now let's do my second example, which would be if I were to solve for an angle. So here's another triangle right here. We'll call this triangle cat, right? I like cats. So we'll solve for my triangle cat. And this time we're given 3 sides, all 3 sides. This would be my side, side, side case. So if I were solving for an angle, we could just pick which angle I want to solve for because it doesn't really matter. I'm given all 3 sides. Let's try one of my new formulas, right? Let's solve for angle T. So given that I'm solving for angle T, we have to be careful which side is the one that we are subtracting up here. So solving for angle T, we would do the inverse cosine of, notice these sides here, the positive sides, are going to be the sides directly around angle T. Angle T is going to be between those 2 sides. So that would be 9 squared plus 12 squared minus 7 squared. And this would be all over 2 times 9 times 12. The 2 sides that are not included. So I'm going to simplify this a little bit before I punch it in my calculator. This would be 81 plus 144 minus 49 in the numerator, 176. All over 18 times 12, which is 216. So I'm taking the inverse cosine of 176 over 216. And that should give me 35.431 degrees. Remember your units. We're dealing with degrees of an angle. Hope that's been a big help. And this should help you out with the homework, especially with these shortcuts. Good luck, and I'll see you tomorrow.